This video, we continue our discussion of surfaces in 3 dimensions. In this one, we're going to talk about cones. All right, so cones have this expression, so this form. How to tell it's a cone? All right, so it has one negative, all powers of 2. And then the third thing, there is no constant, or meaning there's a 0, right? So there's no 1 this time, or any number, it's just 0. Some notes, like the other surfaces, the first one, standard form, helps with traces, just like last time. There's my standard form is up what is above. All right, always directed along the axis with a negative. Remember, it's always the one out, the odd man out, the one that's different than the others. I'm meaning. Sorry, I was zoned out while I was writing. Again, for this one, setting negative variable, and I won't explain it this time, you can look at it, does nothing. So if you were to plug that in, you can take a look at it, set it equal to 0. It's hard to get anywhere with that and understand what should be graphed. Okay, so this is what is useful. Plug in values for negative variable. That are divisible. My brain just blanked. Divisible by denominator. And then that, when you do that, you'll get circles or ellipse. All right, there's the information that will be useful to graph. Pause here if you need to write that down. All right, so let's do an example. We are going to graph one of these things. Remember, it's a cone, so we imagine some type of looking cone. Remember, sometimes in math, it's a bit different. Since everything on the right is 0, I can change the signs. I can multiply the left side by whatever I want. If I multiply by a -1, I get negative z squared plus 9x squared plus 4y squared equals 0. We can do that. That's totally fine. So we're going to do that, and that puts it in a form that we're much more used to seeing. All right. So we have, to show that it is a cone, we have one negative, all squares, and then no constant. Constant 0. All right. That tells me that this is a cone. Okay, so we can start analyzing that. I'd like to put it in standard form. Well, to put it in standard form, because now I don't even know what to divide by, because I don't want to divide by 0 this time. Like used to, we'd divide by what was over there. But now I just need to divide by something to make it look like that standard form. So what you're going to want to divide by is the any common factor of the 3 numbers, or rather the LCM, the least common multiple. So anything that has common factors with all 3 numbers. So a multiple of all 3. So we have 9, 4, and 1. That would be 36. I'm going to divide everything by 36. All right, so that's what I have. So we know that this is along the z-axis, and that's because the negative. Right, so what the instructions told us is to pick the negative, that's z, and we're going to pick z values that are going to divide nicely when I square it with 36. Well, plus and minus 6 would be great here. So, because we're going to get the same value, and then when I plug it in, so let's write this out, x squared over 4 plus y squared over 9 minus, okay, I'm going to get a 1 there, right? 6 squared, negative 6 squared, both of them give me 36, over 36 is 1. So that leads me to x squared over 4 plus y squared over 9 equals 1. That is an ellipse in the xy direction. So I got 2 on the x-axis, right? Because this is a squared. This is b squared, so I got 3 in the y direction. Right, so I have this ellipse. Oh, pause for one moment. Erase what you have. My mistake. This is happening when z is plus or minus 6. So, one sec. We would need to graph this up here at the top, meaning right here. So I'm going to put some axes there. So make one parallel with the x. Make one parallel with the y. All right, cool. Now I have that at 6. I also need the tick marks. So let's go ahead and change this back. Tick marks, I'll just do my best to eyeball it here. I may be way off. Could even do this to make sure. Straighten it out. Yeah, not terrible. All right, and then I also have these tick marks. This is going to be a big, just guessing. You could do up and down ruling if you wanted to. I don't need very many in that direction. I only need 2. There we go. That'll work. Okay, so I get an ellipse there with the x being on 2. There's a truck passing. One sec. I am outside, so it's going to be loud for a moment. My apologies. Okay, so the y will be 3 in each direction. And I have an ellipse here. So I'm going to sketch this ellipse. Alright, so I have a dotted line going this way. I think we probably should have a dotted line there too. This is going to be the front side. So we can have those. Okay, and then we actually have the exact same thing at negative 6. I'm just going to copy and paste. You're going to have to sketch. Erase the things that I don't need. There we go. Okay, so I have that. I also, if I think about what is happening at the origin, think about that, I actually would get 0, 0, 0, which is a solution to my equation right here. If I look up here, x being 0, y being 0, z being 0 would solve it, right? So that's when z equals 0. So that's z being 0. And then that's what gives us this cone-like figure. So I'll do this. We can go all the way through. There we go. Okay, we'll do something like that. That's fine. Then we have this. Yeah. So we get this cone here. My drawing's off, but you can see the cone that's supposed to be there. I think I'm supposed to have lines where I should have dotted lines and vice versa, so I'll just fill all these in. There we go. Just use your imagination to see the 3 dimensions. So let's take a look and see what this is actually supposed to look like. These are pretty easy, I think, to imagine, but we'll take a look anyway. There are our cones. So you can move, change and go down and see further down and stuff like that if you would like. But there they are. All right, so this is a cone.